Okay, welcome. Armin is here from a sunny day. Fortunately, after a couple of weeks, we have good weather here. This live is about the project wrap up, the adaptive AUTOSAR, which started in December 2019, and here we just going to see how the project is actually being designed, and also about the implementation phases, some challenges we faced during the development, and finally, if there are not that much technical issues, we can have a demo of the whole project. So let's start with the design part. The most difficult part, almost for everything, is actually the start to reading the documents to get the big picture of the project, which with the AUTOSAR was also the same issue, definitely. In that case, as many resources recommend to start with the adaptive AUTOSAR implementation, they're going to indicate that the third document actually here, the oral communication API, is a good source for learning how the AUTOSAR is going to communicate with different parts of the vehicle, and how also within the AUTOSAR how different elements are going to interact with each other. And then you get a helicopter view about how you can design the whole system. So I did the same thing. I went with the third document, and it was more or less give me the idea that okay, how the system should build up. But next to that, I found that actually there are too many wake points I need to dive into, and that was the time. Then I find two other documents, the interface guideline and the platform design, which actually helped me in a way to get that big picture of adaptive AUTOSAR. And I just had a recommendation that okay, if I would redo the whole research again from the beginning, then I would start actually with the first document, so the interface guideline, then go to read the platform design, and finally end up with the oral communication API. And as also you can see in the screen, the AUTOSAR documentation is actually available from the AUTOSAR.org. So you can go there, and I guess there are three categories right now: the foundation, the classic AUTOSAR, and the adaptive AUTOSAR, which you can access to the document, which I guess the latest version is R2211. And after getting that big picture, the next challenge for me was to determine the scope of the whole project, because I found out actually the document I found out, the whole document was totally 20,000 pages, and reading was also going to take lots of time, besides the fact implementing the whole thing with one person was actually a nightmare. So I found out before beginning I need to determine the scope in a way that you can be able to finish a project in a reasonable amount of time. So I get the help from the main requirement document from AUTOSAR to have first an idea about how challenging each component within the AUTOSAR can be, and then limit the scope in a certain way to be able to finish the project in a certain amount of time, as I mentioned. And as you can see on the picture, just ignoring the user application part and also the VM part and the operating system interface part, you will end up with this middle block in which you have the different type of components. So I found out there are some essential part I cannot ignore within developing this project. For example, the communication manager, you need to be able to build up this infrastructure for different elements to communicate with each other. And next to that, I found out also the core types are necessary, because there are some cases that, for example, because the all interfaces are based on the C++, you need to actually have some primitive types and also some classes to be able to build up some specific core types within the AUTOSAR. So that was also essential. And the state management and the execution management was also necessary, because the state management is actually something crucial for keeping track of what situation your whole AUTOSAR platform is in. And definitely the execution management also need to interact with the SM to launch different components at a certain amount of time based on the current state of the system. And fortunately, at some point, I found out that the RESTful API is being out of the scope, so it's become obsolete. I guess it was R2211, which was good news for me, because then I could use some standard libraries to interact with any RESTful server. So till now, this part are within this simulator project, but the persistency, the RESTful time synchronization, the cryptography, the update management system, and also network management system became out of scope. But I kept the state management, the diagnostics, the PHM for the health monitoring, the EM, as I said, and also the ARACOM, and also the core type within the scope of the project. And I will go to the next slide, which I will explain about the rest of the layers, which I didn't talk about in this slide. I found that at some point I can bring some of the logic out of the AUTOSAR scope, which they can be reused in different type of project. For example, you have a network communication, and in that case, you can be dependent on your hardware dependency. For example, if you're using the Windows operating system, you're using the WinSocket for your TCP/IP layer communication, and if you're using the Linux, you're using the BSC sockets. And in that case, I thought, okay, you can have an abstraction layer that the adaptive AUTOSAR simulator can talk with that abstraction layer, and after that abstraction layer, you can build up your own operating system interface for your network communication. That's why you have, I can show you the dependency list. In that case, I end up with some in-house dependencies, and one of them was actually the async BSD socket library, and that was actually the fact make it obligatory to use Linux for running the simulation. But if you drop this library from the abstraction layer, you can use your WinSocket library in any case, anything you want to use, and then this simulation can also be run on a different type of machine, in that case the Windows. So that was the reason I found out, okay, I don't need to bring everything within the scope of the AUTOSAR, but I can follow the standard, and at some point, if I have a generic component, I can create a module out of that and bring it outside of the AUTOSAR project. And in that case, your TCP/IP layer is outside, and your communication with the OBD, which I'm going to explain later on because it's the application layer, is also outside. So you have this OBD emulator project, which I also started in parallel with the AUTOSAR, can handle your communication within the CAN network outside of the AUTOSAR project. So you're also not really required to have a specific type of hardware for the simulation, because if you take out that component, you can replace it with your own hardware driver for the CAN communication, and you can basically do the same thing. So this part also became outside of the AUTOSAR project, and I came up with the last part, which you're going to have an application layer, which I explained here that there is a layer. So for an example, I created an adaptive application, and it's called extended vehicle application because it's going to communicate with the REST API of Volvo Cars extended vehicle. And this, if I'm not mistaken, this communication at some point going through the DOIP or DOIP, the diagnosis over Internet Protocol, and the DOIP is also something not really AUTOSAR specific. So for that type of communication, also there is another project also hosted on my GitHub that can be used in a different type of project. It doesn't matter if it's AUTOSAR or anything that require a DOIP can use that project. So you will end up with several in-house dependencies that are not within the adaptive AUTOSAR project, but they can be used in different applications, and AUTOSAR is going to be only a user of those dependencies. Okay, let's go to the implementation. So several places you can find in the AUTOSAR project that it's mentioned that it's based on the C++ 14. At least by the time I was starting the development, the older version was based on the C++ 11, and then later on they upgraded to the C++ 14. And on a real situation, on a real world scenario, you cannot directly use the C++ 14 for actually build up an ECU using the adaptive AUTOSAR platform for the whole design of your ECU, because from ASIL perspective, you need to have a certain amount of safety for running a system, and it's also going to apply to your coding. And for the C++ is actually a case, because you need to follow and obey the MISRA certification while writing your code. However, because it was a simulation, then I really tried to, as much as possible, to follow the MISRA while writing the codes here, but it's not a MISRA certified code, so you cannot directly use this code in a real world scenario. For example, there are some cases that you can see within the project that I ignore the return value of a function call, which is not recommended by the MISRA. And the last thing I need to mention regarding the stack of implementing the adaptive AUTOSAR simulator is the heap allocation, because there was always a concern. Actually, there are different type of ways to tackle the whole situation, but from really classical perspective, in many safety critical systems many years ago, you were not allowed to use this heap allocation. Nowadays, actually, there are ways you can do that in a certain way, but I didn't use any of those techniques here. So if you have a macalloc or on a C level or on C++ using the new keyword or different type of way to allocate something on your heap is being used within the simulator. So there are places that you can find I put something into the heap, and without considering that, okay, you may end up in with a situation that your OS is not going to provide you enough memory for that object, and then your program is going to be in an undefined behavior situation, which you may crash or may end up with something not acceptable. And you can imagine that if that is the case in a real world scenario, then you can actually have a real serious problem. So that's why the heap allocation is being used, but in not a certain way, because it was a simulation, and also using exception, which actually you have in the core type of adaptive AUTOSAR, something called exception. So it's actually a concept, and it's different from STD, the standard library C++ exception, with some consideration of safety critical system design, which I also ignored, because if I go to the project wiki, you can see it from here that in the core type you need to implement the exception based on the adaptive AUTOSAR, but it's being ignored in this case. So I just use the STD exception in the adaptive AUTOSAR Linux simulation. And the reason for that was also some time limitation, but it's somehow aligned with the fact that I already accept the heap allocation, and exception from one aspect actually not allowed in some safety critical system, because they need some allocation on the heap besides the stack, so it can be dangerous because of the reason I mentioned a couple of minutes ago. Okay, after going for development and implementing the code, I found out that I cannot run the whole system at one glance. So there was a situation that I needed too many components as dependencies to run up the whole system. Then I found out, okay, if I made a mistake at some point and I'm going to run the system, for example, 1 year later, when all the dependencies are there, then it's going to be horrible to find out what's actually being an issue if I face or encounter a bug within the system. It was a no-go for me, and it was a time for me to decide, okay, I need to start unit testing any component I develop in the system. Otherwise, I would end up with the situation that, okay, I found a bug in the system, and then I don't have any clue what's the cause of the issue. So that's why after a couple of months of starting the project, I also build up a stage in the pipeline of the project for the unit testing. I use the Google test. So if I write a component, I try to create a unit test for the component in a way that I be sure that in the later development I don't break that object logic. And it's really helped. And I also need to mention that I have this mindset while developing to try to be sure that if I have some dependencies for my unit testing, I should be able to mock up those kind of things. For example, I have some network communication, and there are some logics behind this network communication. But if I want to unit test these components behind the network communication. I still need this network communication. Then I found out, okay, for my network communication, I can have an abstraction layer, and then I can mock up these communications in a way that if you need a client and server and you need to only test the client side, you can have a loopback. So you send something toward that abstraction layer and the loopback send it back to you, or it just mimic the reply for your request, and you don't need to actually have an actual network communication while running your tests. So that was the thing I also keep in mind while developing. So if I have some dependencies, then I can at some point use a dependency injection design pattern for be sure that, okay, for my unit testing, I can inject those dependencies and then I can unit test my stuff. So later on, if I build up the whole system, I can be not almost sure, but pretty sure that, okay, these components individually are working fine, and if something is going wrong, it can be a bug in the system, or okay, in the worst case scenario, I just miss something while covering the test on that object. And yeah, I really like automation generally, but because it just saves time, and that's why I personally really like routines, because it just saves time for me to think about something, so something goes automatically, and I will be happy because of that. And that's why I have the person you can see on the screen, the Doxy Octocatons, which Unreal character who helps me to document my code. And I will dive into that later on in this presentation, but I wanted to mention that maybe it's also not a bad idea. I show you a simple pipeline of the project in the case that if I go to my repository, you will see that I always want to be sure that after every commit to the master branch, my pipeline should pass, and this pipeline is based on, in the first stage, the building of the whole project, which I guess in that case I use the GCC compiler to compile the whole thing, and if it was good, it goes to the test, and in that case I can say, okay, I want to use this C-test, which underwater using the Google test for running my test, and if it's green, then I'm sure that, okay, my commit was good, and if it's not, I'm going to return back which step is failing and then start debugging before it's become too late. Okay, let's go to the challenge I face. Yeah, time, actually, yeah, it was obvious the managing the time was so challenging for me. I had some idea, okay, some components can take, for example, a certain amount of time, but in the reality you always may underestimate or overestimate your stuff. And as I said, it was really obvious, but I had to find some strategies to make the whole development flow smoothly. So after reading I guess maybe the 30% of the whole AUTOSAR, which takes me, as you can see, from January to December 2020, almost a year, I just spent time reading documents to just find the big picture. So one of the strategies I took was first have a big picture in my mind to just be sure that, okay, where am I going? Because we have this equivalent principle in the software design. You always have acceleration on software. You will see you're adding stuff to your software, but At some point you don't know what's this direction of acceleration, in a way that may your software falling down to the ground or is actually going up. And it's a really dangerous fact that at some point, if the software is falling down, it's too late, because you will find out at the point that the software is actually hit the ground. And it was also a conference, I guess 2016, from 0MQ community in Serbia. I guess you also can find it in my LinkedIn page, which you can see some physics rules actually apply to the software. And having this big picture can give you a better idea of where in your software development you are, and it can avoid you too many issues. I took the same strategy to always have the big picture in my mind, to see, okay, now I spent this amount of time on designing this component, and if I overestimate the whole thing, it was good news. But if I underestimate, I would use that feedback for the next module I would design. And it actually made me in a way that I needed to update the milestones, I guess 16 times during the development, because I found that, for example, the outcome is going to take me, for example, 4 months to be developed in a certain scope, because I didn't implement the whole outcome. But at some point I found out that it's actually taking me more than I expected. Then as you can also see on the screen, the E2E, which you have this outcome E2E namespace, became out of the scope at the first stage, because I found out I cannot develop it at this point. And it's not that important in the whole project, because it's just going to ensure that your communication is protected, not from the security perspective, but from the robustness perspective. And then after the project development and developing the main component of the whole thing, I added again to the milestone that I need to develop the E2E, which, as you can see, it became the last stage of the development. But in the first version of the milestone, it was part of the outcome development, which actually was somewhere here. So it was planned to be in October 2021, but yeah, because of those feedbacks and those big pictures, I take it out of the scope and then bring it back because of this dynamic timeline feedback strategy. After managing the time, which was the most difficult challenge to handle, I found out that every time I write a code, I need to have some knowledge for some code I previously wrote on the system. And definitely at some point I needed to go reading the documents again, because usually personally I forgot anything after a week I read about. So I'm terrible in the both short-term memory and long-term memory, but yeah, it's relative. 1 week, I don't know, it's going to be a lot or short, but anyhow, it was not handy while developing this project, because usually it takes me a while to write a code. I'm not that fast coder. I'm really self-critical about my code. I may go through the codes, just refactor them several times, and then I may end up with 100 lines of code in just 1 week. And that's why when I need to interact with other components within the system, I don't have any clue what I wrote, for example, a month ago. And I found out I cannot go in this way, because reading these documents actually going to take lots of time. So this Duxie, this Unreal character that I mentioned in several slides ago, was helping me regarding that. And every time I commit something, I'm going to use the Duxygen format to Duxygenize my code. The Duxygen actually is in the industry for is for a while. I guess it's maybe 20 years. I'm not sure about the number, but it's being a while. We have the Doxygen to document our code. So you have a syntax while writing your comments, and then you run the Doxygen tool, which is developed from a gentleman, which I cannot remember the name, but I know he's Dutch only. By running a Doxygen, you can get the such kind of auto-generated HTML, which you can go through your classes and see which class actually has inheritance and so on and so on. So it's really handy to review your code and having the whole design in one website. So I use the Doxygenize GitHub action, which I wrote myself, to go through the whole source, extracting those Doxygen comments, and run the Doxygen on the build server to finally publish and deploy the web pages generated by Doxygen into the GitHub pages, which actually is a branch next to your main branch, which if you deploy something there, you can access it through the web server of GitHub, so you can see the documents. So if I go through my project, let's see here, you can see the deployment, and if I go there, I guess I can go here and see the whole documentation, which actually my class. But after each unit test which is passing, then I will automatically get these Doxygen document updated by this work stuff which I explained to you. This is the Doxygen GitHub action, and every time after the commit is, and if the test is passing, is going through the repository and generated documents on the GitHub pages. And if you're interested, you can go to the Doxygen marketplace at the GitHub. You can see how it works, and you can see how you can use this GitHub action on your repository, which actually was another challenge for me. Let's back to the slide. I will explain to you. So when I created the Doxygenize GitHub action, I found out that now other people, same as me, are interested in that thing, and I found that I guess now 65 people are also using that action besides me. And if there is something wrong, then I'm a little bit nervous, because now I'm responsible for something on the internet, and I have this feeling I need to support it. And it was another challenge for me, because I guess somewhere around October last year or beginning this year, I cannot remember correctly, but there was a vulnerability in the Git tool, I mean, and the whole actions that's on the GitHub relying on the Git tool actually were failing, because GitHub itself was changing something in the authentication steps, and Doxygen was one of them, because it actually needs to commit something to the GitHub pages branch. And that was the time Doxy was not happy, and if Doxy is not happy, it means I won't be happy, because then my auto documentation procedure is failing, and 65 other people also were not happy, I assume. And that was the reason I need to support the dependencies that actually I created. And it was another challenge I didn't expect, that yeah, you write up some tools and you bring it to the public, but then you also need to support those tools as well next to your main goal project. It was actually the adaptive AUTOSAR. So it actually brings me to the last challenge, that picking up dependencies for your project sometimes can be critical. I guess it was last year we have too many supply chain attack, but security is not really a case here. However, in the real world scenario, it can be something really dangerous, because your software relying on one component and that component relying on other component, and then you may go deep, and at some point you may end up with a buggy components which actually you're not doing anything with that, and from that you may get a backdoor in your own software totally indirectly. And that was the reason that I took a look to my third parties a little bit more carefully. I wanted to be sure that I'm not using really modern C++. So for example, if you look at the project, many of them are compatible with different versions of C++, and none of them actually forcing me to, for example, use C++ 17. And that was the main concern. Next to that was the active support, which if it was a library that the commit was 2 years ago, I would ignore to use that type of third party in my application, because if I end up with something wrong and I found that if there is a bug in the third party, I don't have enough time to dive into somebody's other code and then fix that bug, and you need to create a pull request to bring it back, otherwise you need to fork it, and then it's going to be not a handy situation. And that's why, for example, for the RESTful API, I use the curl, which is actually a really old software. It's been there for a long amount of time, actively supported, really nice code. Even though it's in C, but I just write a wrapper to make it a little bit more C++, and you not end up with using, for example, pointer to function, but using, for example, std function to passing through your callback and those kind of things. And as I said, because of this supply chain attack, I also wanted to be sure that if I'm picking up a dependency, for example, for RXML, which is actually the configuration of the system, the library for parsing them is PugyXML, which is actually a amalgamation. It's a header-only library, and it does not have any dependencies. So you know that you're only dealing with that header, and everything is happening is within that header, and you don't have any other dependencies for your dependency that you're using in your own project. So minimizing the external dependencies was also a factor to me to choose the third party's dependency within my project. And I guess that's the last challenge I had. That previously, I guess at some certain point you get 2 times per year the update from the AUTOSAR community, and I guess nowadays you get it once a year, but it still is challenging because the whole project is just launched in, as I said, December 2019, and till that point there were several versions of adaptive AUTOSAR coming to the market, and I needed to update some of the parts. But honestly, at some point I gave up with updating some of the components because of the time limitation. Some of them actually were still compatible with the newer one, and I didn't find any breaking changes, but I'm also not sure the backward compatibility is guaranteed in the AUTOSAR or not. It's something that still, at least I can say I cannot remember for now, but there was no breaking changes. The only thing was the new components. If, for example, I go for a adaptive communication API, the RCOM, I would use the latest standard for that. So, for example, is actually you can see, I guess, at some point that if I go to the project wiki, you will see that some of if I started, for example, something really old, it has actually all the standard, and because you can see the 2022 version is being also used here, because as I said, I put the E2E at the last stage of the milestone, and for the last part, as I said here, I use the latest or standard. So it means that because these parts are developed earlier, I use that version. But if I was busy with developing the newer component, I didn't follow again the old standard, but I tried to actually use the latest standard by the time I started development. So it's become a little bit messy, but at least they are compatible with each other from one point. So it was the last challenge I had, and the reason was the whole development taking a while, and because of that, I couldn't actually update the whole thing to the latest version. So during development, I faced the releasing of several standards. So yeah, that was the whole thing. Now I hope I can demo you something. Let's take a look if I can. At least because there are some hardware component, I'm not sure it's going to work properly or not, but I'm just giving it a try, and let's see what will be happen. So that's the setup I currently have on my system. From a hardware perspective, I have a V-Link OBD2 scanner, which is actually a standard scanner you can find in the market to find out your OBD errors, for example, your DTCs and those kind of things on your car. And it's the same thing. It's not something for simulation or something. So it's a real OBD2 scanner. And then I did some hacking. So I used this OBD2 connector, which has the different type of wires. But let's see how I end up with the wiring. So the OBD2 pinout, if I search here, I use the ground, I use the power line, and then there was no K line or the 8050 SAE bus, and I only use the CAN for my communication. So if I return back to the picture, you will see that okay, there are 5 wires here, 2 grounds, the power, and the CAN high, CAN low, and then I need to somehow interact with this OBD scanner. So I just provide the 12 volt power to the scanner so it can actually run up, and then I mimic the vehicle CAN bus with my USB adapter. So I have the CAN high, CAN low, but it's actually going to be finally ends up to my system. And if I go to the code, you will see in the configuration that if I can find this one here, I guess at I guess it's hard coded. So if I search for a USB 0, you can see that it's going to listen to that USB port. So I hope it's because it's now connected to my system. Let's go to let's see. Yeah, it's here already. So it means that now this OBD scanner is actually going to talk with the adaptive AUTOSAR, because now I'm listening to that virtual COM board provided by my CAN to USB adapter. And let's see if I have the V-Link. Now I just connected to the V-Link to the scanner from wireless. It can be a little bit confusing because it's the same system, but I try not to confuse it that much. That's why I want to first run the whole simulator, and then I try to explain what's actually happening on the system. So if you build up the system, because it's using my Clang, I use the Clang locally while I'm using the GCC on the build server. It's actually cached something, so the building was fast. Otherwise, I guess depends on your hardware resources. You may need 1 minute for the whole build, and so you need a VCC API key, because, as I said, there is a AA adaptive application for the Volvo REST API, and for that case, if you want to talk with that API, you need the VCC API key, and also you need the authentication 2 code for talking with the Volvo API, which actually hosted outside of the simulator. So also, if you go to your let's close that part, just make it a little bit clean. So here you can find the information how you can create your own, but I already have a account there. So I just create an account on the Volvo Cars developer website. Then it can provide me the VCC API key. So I'm going to copy this key and then paste it here. Press enter. Then it's going to actually ask me for a authentication. So for this one, you need to, let's see, I guess I need to regenerate that because it's actually for 1 hour. So I say for a demo car, I want an extended vehicle API, so generate me a token, and then I'm going to copy this token, and then I come here, paste this token as well, and then I press enter. As you can see, so the machine function group is being configured, and I just want to show you only the most important part. So the state management, it's actually launched, then the DM launched, and then the PHM launched, and finally you will see that, okay, the vehicle, the extended vehicle adaptive application is being initialized, and then the EM is going to fetch the state and then starting a transition, and finally you will see that, okay, now it's being connected to the demo vehicle at the Volvo API side. That's the VIN of the vehicle, and then you can ignore this part for now because that's I just made some configuration for testing the health monitoring. But if you get this part, it means it's actually being good, and then the service discovery also find out that adaptive application being launched. So now I return back to that image, so I can tell you that, okay, now you have more or less at this part, so this USB, just imagine here at that imagine that at that dark side of my screen, there's a real vehicle which actually has a VIN, and it has some OBD parameters, some PIDs, and then my OBD want to interact with that one. And this extended vehicle API is somehow mimicking this vehicle interaction with this OBD scanner. And now I use another application. I guess my doctor can do something good for us here. Yeah. So I have just one trial software for only connecting to my OBD scanner. So it's not something part of the AUTOSAR application. I just want to see if it's working or not. So I use the quick connect. So I'm now connecting via the Wi-Fi to my OBD scanner. So yeah, the chip is being detected. The OBD interface is also being detected. So let's see. Okay, yeah, it's connected to a car, the virtual car, and now if you go to the troubles code, there is no troubles code. So it's actually somehow being tricked that it's actually connecting to a real vehicle, but actually it's the OBD connection to a adaptive AUTOSAR simulator. So the simulator is actually just providing those responses to the PIDs sent by the OBD scanner. And let's start something. I don't know if, yeah, some of them is actually working. So I get some of the parameters from the Volvo API. Some of the parameters actually being some fixed number within the OBD emulator library, which I explained to you is one of the dependencies. So the OBD scanners actually send the PIDs toward the CAN, and then the adaptive application extended vehicle is responding to them. If it has the value itself, then it's going to provide it, and if it does not, then it connects to the Volvo API via the RESTful, and via that it fetched that parameters, bring it back to the DOI protocol, and then finally you will end up with the OBD, and then it ends up here. So yeah, that was a demo about the whole project. And I don't know if is there any question regarding the whole thing or not. I will be happy if I can answer them. But yeah, that was the end of the demo. Okay, there is. Okay, so far so good from Alireza. Okay. If there is no more comment, I can end up the broadcasting, because it's just planned for 1 hour and I have still 6 minutes. Okay, thank you everyone for attending, and I hope you can bring something from this presentation to home, and I I hope it can be a useful material for your real world scenarios development. And I just wish you a good day and hope I can see you in the next time. But apparently I see something on my screen. Let me. Okay, from Mohammed, do I need to have a real OBD hardware to try it? Yes. If you're saying about the need, the obligation is actually, I would say you can actually omit and neglect the whole OBD procedure. So if you go to the code and then, because that part is actually going to have a connection with the OBD emulator, so you can actually drag out the whole OBD emulator from the project, then you don't require anything. But for example, let's do that. Why not? You can. I can do something here. So if I clear, if I run the project and my OBD is actually my USB adapter is not connected to the whole system, then then it actually is still going to launch the whole OBD AUTOSAR, but at some point the health monitoring is actually not going to responding perfectly. So if I return back to my, I hope I still don't need to. So now there is no let's find this. Yeah. Okay. Okay, I just so you can see that at some point that supervision is actually going to say, okay, there is something actually went wrong there, and then still the adaptive AUTOSAR is going to work, but it's going to say, okay, that part of the module is now not responding, because now when you're actually try to listen to that virtual comp, it's going to fail. And yeah, that's one of the way you can still run the program, but you will end up, and still if you want to mimic that OBD simulation, you need to rewrite that part. So that class actually need to be rewritten in a way that, yeah, okay, it's not going to connect to that USB port. Yeah. Any other question? Yeah, thank you, Dawood, as well. Happy to hear that. Okay, ladies and gentlemen, thank you for attending, and have a nice Friday. Hope to see you next time. Goodbye.